Namaste students. In class 10th, we have studied about finding the distance between 2 points in a two-dimensional coordinate system. For example, 2 points P and Q are given to us. P is having coordinates x1 and y1 and Q is having coordinates x2 and y2. And we have to find distance between these 2 points. In that case, we have learned the distance formula as under root x2 minus x1 whole square plus y2 minus y1 whole square. This we have learned for two-dimensional coordinate system. If we have to extend this study of finding the distance between 2 points for three-dimensional coordinate system, in that case, point P will be having 3 coordinates, x1, y1 and z1. Same way for 3D, P will be having coordinates as x1, y1, z1, and other point Q will be having 3 coordinates x2, y2 and z2. And in that case, distance formula will be used as x2 minus x1 whole square plus y2 minus y1 whole square z2 minus z1. So difference between two-dimensional coordinate system and three-dimensional is this one only. In this we have only 2 axes, x-axis and y-axis, and in 3D coordinate axis we are having z-axis also, x-axis, y-axis and z-axis also. So our same way our distance formula has got changed from 2 points to 3 points. Let's do some examples based on this formula. Here we have got a question. They are saying find the distance between the points P and Q. Coordinates of P are 1, minus 3 and 4, and coordinates of Q are minus 4, 1 and 2. For finding distance PQ, let the coordinates of mark it as x1, y1, z1. Coordinates of Q, mark it as x2, y2 and z2. Now finding distance PQ. We have learned the formula is x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Now just inserting the values in this formula, we will be having PQ as x2 minus x1 minus 4 minus 1 whole square plus y2 minus y1 1 minus minus 3, so it will be plus. So it will be 1 plus 3 whole square. Then z2 minus z1 whole square 2 minus 4. Let us calculate minus 4 and minus 1. Minus 5 whole square will be 25. Then 1 plus 3, 4 and 4 square will be 16. 2 minus 4 will be minus 2 and minus 2 square will be 4. Adding all these, 16 plus 4, 20, 20 and 25 will be 45. And if we factorize 45, This will be 3 into 3 into 5. So 3 will come outside. So distance between the two given points P and Q is 3 root 5 unit. In next example, they are saying us to prove that the three given points P, Q and R are collinear. We know that the points are collinear only if they lie on the same line. That means by proving PQ plus QR, distance between PQ plus distance between QR, if this distance is equal to the distance between points PR, distance between PQ plus distance between QR is equal to distance between PR, in that case these 3 points PQR will be collinear. So let us start calculating the distances. First of all, PQ, x1, y1, z1 and x2, y2 and z2. So PQ will be x2 minus x1. So that will become 1 plus 2 whole square plus y2 minus y1, 2 minus 3 z2 minus z1, 3 minus 5 whole square. So what we have got is 1 plus 2, 3, 3 square 9 plus minus 1 square is 1, 3 minus 5 is minus 2, square is 4. So got 14 under root 14. And even if we write the prime factors of 14, no factor will come out. So we'll have to keep it like this only. So value of PQ we have got root 14 unit. Then if we try to find the distance between Q and R, so let us make it x1, y1, z1, and this has x2, y2 and z2. So distance between Q and R will be 7 minus 1 whole square then 0 minus 2 whole square and minus 1 minus 3, minus 1 minus 3 whole square. So what we have got is 7 minus 1, 6, 6 square will be 36, then minus 2 square is 4, minus 1 and minus 3 gives us minus 4 square is 16. Now we have got 40 and 16, 56. 456, if we factorize 8, 7, 7. So we'll be having factors. 2 is coming 3 times and then 7. So 1, 2 will come out and these two will be multiplied. So we have got 2 root 14 units distance between Q and R. We have obtained distance between P and Q, between Q and R. Now next is to find distance between P and R. P is minus 2, 3, 5, x1, y1, z1 and R is 7, 0, minus 1, x2, y2 and z2. So distance PR will be x2 minus x1, 7 minus minus 2, that will be 7 plus 2 whole square plus y2 minus y1, 0 minus 3, z2 minus z1, minus 1, minus 5 whole square, 9 whole square, 81. 0 minus minus 3 is minus 3. Minus 3 square will be 9. And minus 6 square will be 16. 36. 81 plus 9, 90. 90 and it will be 126. Now if we factorize 126, it will be 3 into 2 into 3, 6, 21, means 3 into 7. So factors of 126 are 2, 3, 3, 7. So out of this 3 will come out. So what we will be getting is PR as 3 root 14 units. So as we have obtained, so what we can see, PQ is root 14, we have already calculated, then QR is 2 root 14, and just now we have obtained PR, that is 3 root 14. So what it shows? It shows that from equation 1, 2 and 3, PQ plus QR, that is root 14 plus 2 times root 14, that gives us 3 root 14. And what is 3 root 14? That we have obtained is PR. So ultimately what we have got, PQ plus QR is equal to PR. It shows that 3 points are lying on the line. So points P, Q and R are collinear. In third example, they have given us 3 points A, B and C, and they are asking us whether these points can form a right angle triangle or not. As you know, for right angle triangle, we need to satisfy Pythagoras theorem. That means if we calculate AB square, BC square and AC square, and sum of two squares is equal to third square, if it is possible, then this will be a right angle triangle, and if it is not so, then they will not be forming a right angle triangle. So let us calculate distances AB, BC and AC and then square them. First of all, for AB, A is 369 and B is 10, 20, 30. So AB will be x2 minus x1, 10 minus 3, that is 7 whole square, plus 20 minus 6, 14 whole square, 30 minus 9, 21 whole square. So that will give us 49, 196 and 441. And sum will give 54, 90, 590. That gives us 686. Now for finding square, if we square both sides, we are getting AB square as this root will go 686. Now BC square or BC, whatever you want to calculate. B is 10, 20, 30 and C is 25 minus 41 and 5. So BC will come out to be 25 minus 10, 15 square plus minus 41 minus 20 minus 61, 5 minus 30 minus 25 square. Now squaring and adding these values. We have written the squares of these numbers, 15 square, 61 square and 25 square. And after adding all these, we have obtained 4571 under root. So BC square came out to be 4571. Same way, if we calculate the distance between A and C and then take its square, we will be getting 2709. Now what we have got? We have got AB square as 686, AC square as 2709 and BC square is the highest value, that is 4571. So if we add AB square and AC square, this addition should be equal to BC square. If we add AB square and AC square, we are getting 606 plus 2709, and what are we getting? 3395. Is it equal to BC square? Not at all. Not equal to BC square. Then by converse of Pythagoras theorem. According to converse of Pythagoras theorem, if square of two sides is equal to square of the third side, then the given triangle is a right angle triangle. But here it is not happening like that. So we will be writing, therefore, points A, B and C are not the vertices of right angled triangle. In example number 4, they are saying find the equation of set of points such that a condition is given that PA square plus PB square is equal to 2K square. A and B points are given to us. A is given as 3, 4, 5 and B is given as -1, 3 and -7. P is not given to us and this condition is given. So let us take P as having coordinates as x, y, z. So what we have to do is we have to find PA square and PB square. First of all, PA square will be x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus x1 whole square. Root of the formula has become square this side. So let this be x1 y1 z1, or you can mark it as x2 y2 z2 and x1 y1 z. So x2 minus x1, this is x minus 3 whole square plus y minus 4 whole square plus z minus 5 whole square. Now if we open the squares, we will be getting x square minus 2ab will be getting minus 6x plus 9. A square minus 2ab plus b square. Then a square minus 2ab will give 8y and plus b square will give 16. Same way here, a minus b whole square will give us z square minus 10z plus 25. As we have obtained PA square, in same way we can obtain PB square also. For PB square, we will be taking point B. B is -1, 3 and -7. It will be equation 1. Square will be x minus a minus plus 1. So x plus 1 whole square plus minus or minus plus. Z plus 7 whole square. Now opening this one, a plus b whole square. X square plus 2x plus 1. Here a minus b whole square. Y square minus 6y plus 9. And here a square plus b square plus 49. Let this be the second equation. Now this is pa square and this one is pb square. According to question, pa square plus pb square is equal to 2k square. So if we add equation number 1 and equation number 2 and put it equal to 2k square. So according to question, pa square plus pb square is equal to 2k square. So adding equation 1 and 2, adding 1 and 2, we will be getting p square plus pb square. 2x square, then so give 2x and minus 6x will give minus 4x. Then this 1, 9. 1 and 9 gives us 10. 10 and 49 gives us 59. And from here 9 plus 16. 25 and 25 gives us 50. So we'll be getting 109 from the constant terms. Then y square and y square gives us 2y square. Minus 6y and minus 8y will give minus 14y. This we have already done. And z square and z square will give 2z square. 14z and minus 10z plus 4z. So by adding equation 1 and 2, we have got this result. Adding equation 1 and 2. Now, as we have written, according to question, pa square plus pb square equals 2k square. Therefore, we have 2x square. We'll be keeping x square terms at the front. 2x square plus 2y square plus 2z square. Then minus 4x minus 14y minus 4x minus 14y, and then is plus 4z. And this we have plus 109 equals to 2k square. So this is the equation which they were asking, find the form the equation between the given points. So we have obtained the equation which was being asked. This is the required equation. So in today's lecture we have learned about the distance formula for 3D coordinate axis, and we have done related examples for this formula.